So today we will be dividing rational expressions. And in order to divide rational expressions, you're just going to rewrite the division problem as a multiplication problem, and you only flip the second fraction. So I think you remember from dividing fractions from way back when, it's keep, change, flip. And that's what we're going to be doing again, but we're only flipping the second fraction. As always, if necessary, factor the top and or the bottom. So if you can factor, you have to do that first. Then you're going to multiply the top by the top, the bottom by the bottom, or you could cross cancel first. But either way, your final answer has to be completely simplified. So you need to decide how you're going to do the simplifying. For each of these problems, when we find the quotient, we're going to assume that no denominator is equal to 0. So like we did the restrictions on the first day of the lesson, we're not going to worry about restrictions here because we're telling you you're never going to have a 0 as a denominator. This first one is old. All right, this first one goes back to exponents, which is unit 2. There's nothing to factor. They're all monomials. But if you remember from the first time we did this unit, it was going to be keep the first fraction as is, 6xyz squared over 5x squared z, change division to multiplication, and flip the second fraction, which means 3yz squared is the new numerator, 10x squared y is the new denominator. With having all monomials here, instead of cross-canceling, I probably would multiply straight across the top, straight across the bottom, and then simplify from there. So if I multiply straight across the top, the numbers give me 18, x's are just x to the first, the y's total out to y squareds, and the z's total out to z to the fourth. On the bottom, 5 times 10 is 50. My x's become x to the fourth. I've got one of the y's and one of the z's. Now all that's left to do is simplify this. So both 18 and 50 are both divisible by 2. So that means 18 50ths becomes 9 25ths. There's more x's on the bottom by 3. There's more y's on the top by 1. And there's more z's on the top by 3. This becomes your final answer. This part's nothing new. This is old stuff. The new stuff's going to start next. So again, it's division, so we need to do keep, change, flip. So we're going to keep the first fraction as is. It's going to be 3x divided by x plus 2. We're going to change division to multiplication, and we're going to flip the second fraction, so x plus 2 is on top, and 3x squared minus 3x is on the bottom. Then you start asking the questions, do you have anything that's factorable? And can you factor the top fraction? And you can't, so 3x is as is. Can you factor the bottom denominator x plus 2? And you can't. So I would say the fact that it's a binomial and you can't factor it, parentheses should go around it. The numerator of the second fraction is also an x plus 2, is not factorable, so put parentheses around it. But the denominator is factorable. I can factor this bottom by a GCF, which is 3x, and what's left over is an x minus 1. So really what's happening is you have a problem that looks like this. 3x over parentheses x plus 2 times x plus 2 over 3x, x minus 1. When I start looking for common factors, this parenthesis, this binomial x plus 2, cancels this binomial x plus 2. What you're left with, because you have no more binomials to factor, is 3x over 3x, x minus 1. But 3x divided by 3x is just 1 also. So your final answer becomes the binomial on the bottom with a 1 on the top. Let's take a look at this next one. We know we have to keep, change, flip. So what I'm going to actually do is I'm going to sort of keep, change, flip, and factor all at once, which means if I start factoring this guy right here, it's a GCF, and I've got a 2 with an x plus 2 over. When I factor this, it's an IM, and here I know that I've got an x, whoopsie, get this back up here. Sorry, let's fix that. Okay. So now when I factor this one, I've got the bottom is going to be x plus 9 and x plus 2. Now here I'm going to sort of factor and flip at the same time. So I know I have to multiply, but the next thing that I'm going to factor is this bottom, but it's going to go on to the top, right? Because that's what happens when you do keep, change, flip. So that becomes an IM, and it's going to be, in this case, x plus 9, x plus 5. And now I have to factor this top, which really turns into the bottom. And this is going to be a dots, and it becomes x plus 5, x minus 5. So I sort of did the keep, change, flip, and factor all together. Now start looking for common pairs. So what do we have? X plus 2 on the top and x plus 2 on the bottom, the whole binomial. We've got an x plus 9 binomial for another full x plus 9 binomial. And then we have an x plus 5 for the other x plus 5. So all of those things cancel out to give you a 1. And what's left is your final answer, a 2 on top and a binomial x minus 5 on the bottom. Make sure you're good there. Okay, take a look at this next one. Again, I'm going to do keep, change, flip all at once. So I'm going to keep this one as is, and I'm going to factor the top by I am. And this becomes x plus 3, x minus 2. The bottom is also I am, x plus 3, x plus 5. I know that I have to do multiplication, right? So it's keep, change, flip. And then I'm going to do that thing again where I know that the bottom gets factored to the top and the top gets factored to the bottom. So if I factor what's in yellow, it's also I am. It becomes x plus 5, x plus 4. If I factor the top, which turns to the bottom, right, because I had to change flip, becomes x minus 2, x plus 1. Let's see, where can we cross stuff out? X plus 3, x plus 3. It's okay that they're in the same fraction. They can be in same fractions or different fractions to cancel, but it has to be the exact same binomial. I've got a package here of x minus 2, x minus 2, and I've got an x plus 5 for an x plus 5. Nothing else can cross out. Final answer, this binomial x plus 4 over this binomial x plus 1. It's kind of fun sometimes to be able to factor all these things and then cross them out. One more to go. Same idea, keep, change, flip. So keep, change, flip. The first numerator is a GCF, x minus 7. The bottom is an I am, x plus 5, x minus 3. We've got to change and flip. Again, just remember that the bottom goes to the top and the top comes to the bottom. So the yellow one becomes x minus 3, x minus 2. And the green one becomes 7 as a GCF outside a, I'm sorry, not a 7 GCF. Erase that. It's a 3 GCF outside of a 7 minus x. All right, crossing stuff off. Let's see. An x minus 3 and an x minus 3. I also have this thing now. I've got, let me move this over. This doesn't want to move. I'll take the blue. I also have this thing, x minus 7 and 7 minus x. These aren't the same. These things are opposites, right? Because I've got subtraction with the same numbers in there, so they turn out to be opposites, which means when these guys cross out, they're not left as a 1, they're left with a negative 1. So somewhere, top or bottom, I'm going to put a negative 1, and for no reason, I'm putting the negative 1 down here on the bottom. Nothing left to cross out. So the final answer on the top becomes an x with an x minus 2. On the bottom, it's an x plus 5 with a 3 times a negative 1, which means I'm going to put the negative 3 there. Okay, so that's the answer. If you're someone who chose to put the negative on the top, then your answer would be a negative x minus 2 over a positive 3x plus 5. Again, it doesn't matter where the negative goes. It just got to go somewhere. Okay? And that's it. Good luck on the homework.